Hello everyone, it's September. It's December 15th. I finished. Alright, two things. First, this question, the average passing ratio from yesterday. I was not able to do it completely by myself, so I checked the hint. And from the hint, I knew how to do it. It's a max heap. So every single step you try to add the student to a class where the delta of the increased ratio is the maximum. And every single time when you need to add a student to a new class, you choose the class that will give you the maximum delta in the passing ratio. So yeah, I was able to solve it, but reading the official solution, it had a better implementation of the same idea. So that's that. And another thing I want to say is today I finished reading Robert Heinlein's The Moon is a Harsh Mistress. It was such a good book. I enjoyed it very rarely. I mean, the masters of the past era, all those classics, not a lot of them. Like I don't enjoy all of them. Some I did, but not all of them because some of them are, I don't like the way they write. Some of them are just too old, like H.G. Wells. I think that was just too old, and then the prose just I don't really feel it. Some of them were just and I don't know what they're talking about, and I'm referring to the necromancer, the neuromancer, right? The neuromancer. I mean, I tried so hard to understand it, try to follow the story, but the way it was written, it's just Gibson, right? The way it was written, it just I can't follow. But there are classics that I really enjoy. Most of Arthur C. Clarke's work, I love a lot. Childhood's End, definitely one of my top three sci-fi stories. And I think this one, Heinlein's The Moon is a Harsh Mistress, is there in my opinion. Very, very good. I mean, I'm saying this even though I don't like the prose. I don't like his way of writing. I mean, I know why he wants. I know why he did it, because it was the way that the Luna people talked. But honestly, I was not a big fan of it. But despite that, the story was just good. The ideology behind, and it was just a good one, a very, very good one. I think I'm gonna read more of the classics. Definitely should. I think you can always write a sci-fi story, a fantasy story, whatever. You can always write it, create your own world, tell a story. Yeah, I mean, everybody can do it. I also have read some books just like that. They have a interesting idea, and then they just start making stories. But those are just very flat. They're just like the stuff you read on the plane, and you just forget about it afterwards. Yeah, I've read some of those, but these classics are the ones that really, has a place in history, in the sci-fi history, are the ones that are more than just stories. They have stories and they have characters. They have something that hook you, but they also have thoughts. They have great quotes. Like I had like 3 quotes from this book left me a great impression. And it's just these things, right? These things really make the book stand out among its peers. Yeah, really great book. All right, enough of the book talk. We are going to solve this fast. Oh, I'm looking at an easy problem. It's good because I really want to go to bed early today. All right, final array state after k multiplication operations. You are given an integer array nums. It is a k multiplier. You need to perform k operations on nums. In each operation, find the minimum value in x in nums. If there are multiple occurrences, select one that appears first. Replace the selected number x with x times multiplier. Return the integer array, denoting the final state of nums after performing. Oh, it's just a priority queue. Just a priority queue. Yeah, just a priority queue. Very straightforward. And I don't have to create my own. I think I just go with it. Ugh. Right, and now we say I smaller than n, I plus plus. Then we're gonna put pq.push value first. So nums I and I. Okay. And then we'll do k operations, right? So while k is larger than 0, then we say auto element equal to pq.top, pq.pop, and element.second. We just pq.push element.first times multiplier and element.second. Okay, vector int res, and now we say while. Now you probably can just go through this for. I'm not sure. I think I can. Then we say res element.second equal to element.first. Let's see if it's allowed. Invalid range expression. I guess it's not allowed, which is fine. We can say while pq.empty. Right. Pq is not empty. Top. Actually, no. O log n is to push, and then we have k log n. And then the last one is O log n again. Oh. is not what I had expected. Oh. Oh my god. That's... Well, it happens. Oh. And then we have to say greater. Right? Oh my god. Yeah, I forgot that in C++ it's always a max heap. Ooh, there is a way. If you don't want to write all that, you can do negative, right? Yeah, you can always do that, but it's okay. Alright, so we're done with this easy problem. Nothing really to see. I don't think there will be even other solutions. Oh, make heap. What is this? Oh, wait a second. Oh, you can push. Oh yeah, that's fine. You can combine these two. That's true. But it's okay. So make heap, and then can call greater. Yeah, that's all right. Okay, what are we going to do with this? Continuous subarray. Oh, I use a heap. I think the ideal is we want to try a monotonic array on this. Yeah, we want to try monotonic array on this. Basically, we'll create two monotonic arrays, two monotonic deque. One is monotonic array increasing, which help us keep track of the smallest value. The other is monotonic decreasing, which will track the max value, right? And each pair of indices. So what we want is every time we add a new number, right? We add a new number. We need to see if the new number can be added. All right, if it can be added, yeah, then we add whatever. If it's too small, right? Or if it's too big, then after we add it, we have to update the left. So it's a 2-pointer. The left is updated by we compare the two monotonic stack. Whichever is smaller, need to move forward. We move forward until it's the minimum value is good. Okay, let's double check that that's the case. Yeah, we'll have a left, we'll have a right, we'll have 2 decks. We'll make the current. Wait, hold on, this is different. So we add it first. Okay, we add it first, then we shrink. Yeah, it's fine. We add it first, then we'll shrink. Is a shrink? Ah, yes, we add it first. So it's not really compared to what's been added. It's compared to the overall, right? Like if it's too big, then we need to shrink. Then whoever is at the front gets shrink, right? This at the front, then we'll shrink it. This at the front, shrink it. Then we keep going until we cannot shrink anymore. Then we have the left, so we update the left, and then we say yes. Very straightforward. Okay, I'll just not do it today. It's late. I'll see you guys tomorrow. Adios.